Our lesson today, students will be drawing polygons in the coordinate plane. They will find the lengths of segments and solve problems that involve area and perimeter. In our first example, we're given a coordinate plane, just the first quadrant of a coordinate plane, and we're asked to draw the polygon with the given vertices in the coordinate plane. So we want to take a look at our ordered pairs, and the first set of ordered pairs says to take 0, 0, put a point, and 5, 7 over 5, up 7, put a point, and then 7, 4, 2, 4, 6, 7, 2, 4, 7, 4. This is point A. This is point B. This is point C. We connect those points with straight lines using a ruler, and we have a triangle for the first set of ordered pairs. Second set of ordered pairs we'll do in red. Point W is located at 4, 4, so 2, 4, up 4, put a point, call it W. Then we have a point at 7, 4, so that's right 7, 2, 4, 6, 1 is 7, up 4, put a point, that's X. Next point is at 7, 1, 2, 4, 6, 7, 1, put a point, and we have a point at 4, 1. Right? Connect those points with a straight line, and let's do that in red. Connect our point, so we have segment here, segment here, segment here, segment here. Alright, I didn't label all my points. 4, 1 should have been at point Z, and 7, 1 is Y. So it looks like we have a square because all three sides are equivalent. Let's draw problem 3 in blue. Point F is located at 1, 3, over 1, up 3, put a point, call that F. Point G is located at 3, 6, over 3, up 6, put a point, and that's G. Then we have 5, 6, so over 2, right, or over 2, 4, over 5, and up 6, 2, 4, 6, that's going to be point H. And we have 3, 3, right 3, up 3, put a point, and then label that point J. Connect those points with a straight line. Alright, let's make those blue. So there's segment here, segment here, segment here, and segment here. So that looks like that is a quadrilateral. It's a 4-sided polygon where both pairs of opposite sides are parallel. And let's do this last one in green. We have a point at 1, 4. So we go over 1, up 4, put a point. Gonna label that P. We have a point at 3, 5. So it's over 3, up 5. 3 and 2 is 5. Gonna label that Q. Q. And then we have 7, 3, 2, 4, 6, 7, 3, put a point, label that R. Then we have 6 and then 1/2. 2, 4, 6. 6, 1/2 would be located right here, and we're going to call that point S. And then 2, 1/2 would be located here. Notice that when I graph the point 1/2, it is here 0, here's 1. 1/2 would be right in between where 0 would be located and 1 would be located. I'm going to call that T. Right, connect those points in with straight lines using a ruler. Let's do that in green. Let's see what kind of green. We'll do this green here. Connect the points. We go here, 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 and here. So that's just a little quick review of how we would graph points in one quadrant, and we create various polygons. Let's look at our next page. We're asked to graph the vertices of the rectangle, and we're asked to find the perimeter and the area of the rectangle. All right. Our first point is located at 2, 7, so that's over 2, up 7, 2, 4, 6, 7. Put a point. I'm going to label that J. We have a point at 4, 7, so 2, 4, up 7, 2, 4, 6, 7. I'm going to label that K. A point at L, which is over 4, and then up 1.5. 1.5 would be in between 1 and 2. So there's 1.5. I'm going to call that L. And then we have 2, 1.5, and we're going to call that M. That's a sloppy M. That's a little better M. We're going to connect our points. We'll use blue segments here. And let's see, connect the points. Oops, let's undo that. Had a little trouble with that. Undo that. Alright, label that M. And connect the segments. I'll just draw lines here. It's a rectangle. Try to be neat. And there we go. Now we're asked to find the perimeter and the area. So in order to find the perimeter, we need to know the length of each segment. And we would need to know the length of each segment to find the area too. So when we find the length of the segment, I'm counting how many horizontal units long is this segment. It's 1 unit, 2 units long. How many units long is the vertical segment? It's 1, 2, 3, 4, 5 and a half. So that's 5.5. Which means this parallel segment is also 5.5, and this segment up here would also have to be 2. Let's start with our perimeter. Perimeter is equal to 2 times the length plus 2 times the width, or we can just add all 4 sides together, but I'll use a formula. 2 times the length, which is 2, plus 2 times the width, which is 5.5. Right? We replace the variables with each of those measurements. Perimeter is going to be equal to 2 times 2, which is 4, plus 2 times 5.5, which would be 11. 4 plus 11. The perimeter is going to be equal to 15, and we would just say 15 units. We don't know if they're linear, well, they're linear units, but we don't know what linear units we'd be using there, so you just say 15 units. And that would be the perimeter of the rectangle that we just drew. If I'm doing the area formula is equal to length times the width. So the area is going to be equal to the 2, which is our length, times our width, which is 5.5. And when we multiply 2 times 5.5, that's going to be an area of 11, and those would be square units. All right, we circle or box our answer. So let's take a look at a couple more. Now we're going to graph in 4 quadrants. All right. Now when we graph in 4 quadrants, remember the first value is our x direction, second value in the ordered pair is our y direction. Right, let's do problem 6 first. 3, -2 means I go 3 in the x direction, so I would count 1, 2, 3, and I would go down 2 in the y direction. I'm going to put a point. I'm going to label that R. Point S is located at 7, -2, so that's right 7, 1, 2, 3, 4, 5, 6, 7, down 2, and I put a point. I'm going to label that point S. 8, -6 is over 8, 2, 4, 6, 8, 2, 4, 6, 8, -6 would be here. And then we have 1 and -6 would be over 1, down 1, 2, 3, 4, 5, 6. There's 1, -6, and that would be V. And I forgot to label that T. We connect our points. Alright, and let's do that in blue. So we connect our points. Connect, 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 and connect. Now we have the shape of a trapezoid, where we have exactly one pair of parallel sides for our quadrilateral. In order to find the area of the trapezoid, we need to know B1, which is this base down here. We need to know B2, and we need to know the height. So let's take each one of those measurements one at a time. Let's find the first base. I count 1, 2, 3, 4, 5, 6, 7 units long. My second base, 1, 2, 3, 4 units long. The height, I'll do in a different color so that it stands out. It's 1, 2, 3, 4 units long. And remember, the height has to be perpendicular to our bases. And the bases of a trapezoid have to be the parallel segments. So now we use our formula to find area. Area is going to be equal to 1/2 times the height times B1 plus B2. It's in parentheses. So my area is going to be equal to 1/2 times my height, which is 4, times B1 plus B2, which would be 7 plus 4. 7 plus 4 is 11. 4 times 11 is 44. 1/2 of 44. My area is going to be equal to 22. And those would be square units for the area for problem 6. Problem 7, 2 in red. My first point is at -3, -4, and it's labeled point A. -3 in the x direction would be 1, 2, 3 units to the left. 1, 2, 3 down 4 units, and I'm going to label that A. Point B is located at -3, 5, which is left 3. 1, 2, 3. Up 5. So that's 1, 2, 3, 4, 5. Oops. Put a point. And then we label that what, B? Point C is located where? 2, 5. So that's right 2. 1, 2. Up 5. 1, 2, 3, 4, 5. There's 2, 5. Label that C. And D is 2 in the x direction. Down 4 in the y direction, which would be here. And I'll label that point D. We connect our points. Alright, I'll use red segment. Nope, wrong one. Use red. And we go here. Oops, a little long. Go here. And here. Alright, and in order to find the area, we need to know the length of each segment. So the horizontal segment is 1, 2, 3, 4, 5 units long. So that means the other horizontal segment is 5 units long. The vertical segment is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And it means that this vertical segment is 9 units long. To find the area of a rectangle, we use the length times the width. So I write my formula. Area is equal to L times W. My area is going to be equal to the length of 5. My width is 9. 5 times 9 is going to be 45. And those are square units for the area. Alright. Let's look at our next couple problems. It says to graph each figure and classify it. Alright. My first point, point G, is located at -4, 1. So that's left 4. 1, 2, 3, 4. Up 1. Put a point. Label it G. My point H is at 4, 1. So that's right 4. 1, 2, 3, 4. Up 1. Put a point. Going to label that H. Point I is located at 3, -3. So that's right 3. Down 3. Put a point. And I label it I. And then point J here is located at -1 in the x direction, down 3 in the y direction, put a point, and we're going to label that J. We want to connect our lines, connect our points with straight lines. I'm going to use red here. Connect, 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 and connect. Looks like we have a trapezoid. To find the area of the trapezoid, we need to know the length of our bases. 1, 2, 3, 4 units long here. And this segment, 1, 2, 3, 4, 5, 6, 7, 8 units long. Remember, the bases of the trapezoid are the parallel segments. I also need the height. Do it in blue so it stands out. The height is the perpendicular segment to the two parallel bases. My height looks like that's going to be 4 units long. We're asked to find the area. So I write my formula. Area is equal to 1/2 times the h times b1 plus b2. My area is going to be equal to 1/2. My height is 4. b1 and b2 would be 8 plus 4. So my area is going to be equal to 1/2 times 4 plus 8 is 12. 4 times 12 is 48. 1/2 of 48 is going to be 24 square units for the area of that trapezoid. And the last problem we'll do today. Point X is located at -7, 2. So that's left 7. 1, 2, 3, 4, 5, 6, 7. Up 2. Put a point and I'll label that X. Point Y is at -7, 6. So -7, 2, 4, 6. Here's -7, 6. Call that point Y. Point Z is at -4 and 2. There's point Z. So we're talking about this figure here. Let's say do blue. And so I draw a line here, connect here, and connect here. Looks like it's a triangle. The formula for the area of triangle, area is equal to 1/2 base times height. Area is equal to 1/2. Now what's my base? My base is 3 units long. My height here is 4 units long. So it's 1/2. 3 times 4. 3 times 4 is 12. Half of 12 is 6. So my area is going to be equal to 6 square units. Alright. I think that's it for today. Nope, we have 2 more. Okay. So let's try these 2 and see where that leads us. Alright. So point K is located at -2, 2. Left 2, up 2. Put a point. Point L is located at 3, 2. Right? That's L. This is K. Point M is located at 2 and -2. Over 2, down 2. Put a point. And let's see. Point N is located at -3 and -2. That's -3 and -2. Put a point. This is K. No, that's N. And what was this? This was M. And now we connect our points. Use blue. Connect. 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 And connect. Get a collection of points in a straight path. Right, that looks pretty good. And let's find the area. Right, we're asked to find the area. So the area, it's parallelogram. So the area is going to be equal to the base times the height. So the area is going to be equal to, we need the length of the base, which is 1, 2, 3, 4, 5 units long. I need the height, which is this distance here. That distance is, let's see, let's draw it so that we can see it. That's 4 units long. So the area is going to be equal to 5 times 4. Area is going to be equal to 20 square units. Right, let's put a box around that. And now the last problem today, problem 21. They ask us to find Q. Q is located at -2, 4. Put a point. Label it Q. Point R is located at 0, -2. 0 in the X direction means I don't go left or right, but I go down 2 in the Y direction. Put a point. I'm going to call that R. And point S is at -4, -2. Put a point. I'm going to call that S. Looks like we have a 3-sided figure, so it looks like that's going to be a triangle. So we connect our points, connect here, connect here, and we write our formula for the area of a triangle. Area is equal to 1/2 base times height. Area is equal to 1/2. My base here is 4 units long. My height is, let's see, 1, 2, 3, 4, 5, 6 units long. If we're talking about the length of this segment, right, that's 6 units long, that's 4 units long. So 1/2 of 6 times 4, 6 times 4 is 24, half of that is 12, so the area is going to be 12 square units. All right, that's the end of our lesson. I hope that's been helpful. All right, take care.